Hello, hello. 11.2 is actually getting into probability and figuring out outcomes. Whenever we're talking about probability, we always have a fraction or a percentage. On the bottom is always going to be your total. On the top is always going to be whatever you're talking about. What are you wondering? So like the probability that you hit a red light, the probability that you pick the Queen of Hearts, things like that. But the bottom of your fraction, because you will have fractions with probability, is always your total. First, we have experimental probability. This is when you take data down. This is if I had you sit at the desk and flip a card over and then you record that data. And then you flip over another card and record that data. We always would use either a table or certain outcomes that have occurred. So when I'm talking about probability of an event, the number of trials, how many times did you pick a card? And out of those times that you picked a card, how many were they a seven of spades? Things like that. So if I have this problem of 60 vehicles in a teaching parking lot, this is my total. Total should always go on bottom, so I know 60 should go on bottom. 15 are pickup trucks. What is the experimental probability that a vehicle in the lot is a pickup truck? So my intended outcome are pickup trucks, so it would be 15 on top. So then my experimental probability of this would either be 0.25, or else you could say 25% chance that it is a pickup truck. So my first question, what is the probability a quarterback will complete his next pass if he has completed 30 of his last 40 passes? So there's a total of 40 here, and he has completed 30 of the 40. So now I have my intended outcome over my total. So that's going to be equal to 3/4 or 75% chance that he will complete it. Right now I want you to pause the video and try this next problem by yourself. And you should have gotten 80% chance. Now the next type of probability we're going to be dealing with is theoretical. This is using predetermined outcomes. So if I have a deck of cards, there's 52 cards there, what's the probability of choosing a king? Or if I'm rolling a dice, what's the probability of rolling a 5? That's my first question. So when I have my theoretical probability, it's still total on bottom. So it's the total outcomes over the probability that you are talking about. So it's still division, it's still a fraction. So if I get 5 when I roll one standard number cube, so you have to know what is a number cube. That's the same thing as a dice. So on a number cube, there's a total of 6 different sides, and only one of those sides is going to be a 5. So my probability of getting a 5 would be 1/6. What's the probability of getting a sum of 5 when you roll 2 standard number cubes? So I have to think, I'm going to draw my division bar first. So with my division bar on the bottom, the total number of outcomes. Well, I have 6 outcomes when I roll the first dice or die, and I have 6 outcomes when I roll the second die, because those are my options, because there's 6 sides. So I have 2 different rolls, so I have to make sure to multiply those. Now, getting a sum of 5 when you roll 2 number cubes. So now you have to think, how many sums of 5 could you have? And I wrote those outcomes over on the side. So let's say that red is one die and blue is the other die. I could roll a 1 and a 4, a 2 and a 3 and a 2, or a 4 and a 1. So that's going to be my 4 different outcomes here, because I have 4 different options to have a sum of 5. So now when I simplify this, this will be 4 over 36, which is going to be 11%. I want you to attempt these next 2 theoretical probabilities by yourself. First outcome would be 1/6, because there's only 1 3 on a 6-sided die. And the second one would be 2 out of 6, because you could have a 2 or a 4, and there's still 6 outcomes, 6 total options, so it would be 1/3. The last type of probability we're going to be going over is geometric probability. So batter strike zone depends on the height and stance of the batter. So I'm looking for what's the probability that the pitcher will get in this high strike zone right here. So we're talking about area. But whenever we're talking about probability, I still have my total on the bottom. My total strike zone here is going to be this big length. So I'm looking, what's the area of the total strike zone? So this length is going to be 17, and the side length is 22. Again, I'm wondering, what's the probability that the pitcher is going to get it in the high strike zone? So now if I look at this area right here, that's going to be 4 times 6, because I'm looking for the area of my rectangles. And I would get 24 over 374, because that's my area of my small high strike zone over the area of my whole strike zone. So if I were to divide that out, and I typically, when have problems like this, if I don't tell you how to represent it, write it as a percentage. So this would be 6% chance that that pitcher will get it in the high strike zone. Make sure you make sure that you took good notes, and have a wonderful day.